Okay, welcome back. So just before again we look at some examples of how to find domain and range, just to see the formal notation, just so you've seen it before in case you see it in a textbook, or again for those of you looking to take 3U next semester, it's good to see this kind of formal notation. I'll show you guys a shorter form that we're going to use afterwards, but essentially what we say for the domain. Now this looks pretty complicated, but what this is read as D for domain equals in brackets we have x. This is a Greek letter epsilon with an r. So this means x is an element of the real numbers. And then we have a vertical line, which means such that. And then there's some restrictions that occur afterwards. So we say that x is an element of the real numbers such that, and then if there's any restrictions on x, we would state them there. Similarly for range, it's the same idea, except it's y. So we say the range is y is an element of the real numbers such that, and then list whatever restrictions there are. So this will make more sense when we see some examples. So once we take a look at this first graph right here, we're looking for the domain and range. So what we have here is a line. And again, for the domain and range, we're just trying to list all the possible x values or y values that would exist on this graph. Okay, so for the domain, what we're going to do, and again, if you look on this graph, because this line continues forever up and to the left, any x value over on the left here exists. So x exists everywhere until we reach the point where this line stops here. This solid dot here means the line has stopped, doesn't continue on. So the only x values that exist are ones that are to the left of this dot, left of the right endpoint of this line. So, and if you see that the point occurs when x equals 3, the only x values that can exist are the ones that are smaller than or equal to 3. So the way we're going to write this for the domain, the formal way to write it, we would say that x is an element of the real numbers such that, and then we have the restrictions. So the only possible x values that exist on this line are the ones that are to the left of 3, so the ones that are less than or equal to 3. So we'd say x is less than or equal to 3. Okay, so whatever x value exists on this line, it's going to be less than or equal to 3. This would be the formal way of writing it, okay? And I'll show you the shorter way of writing it right afterwards. But for the range, we're going to do the exact same thing, but we're going to look at the y values. So for the range, again, the line ends down here. So the only y values that exist are the ones above here. So the lowest y value on this graph is down here at -6. Okay, so for a range, we say y is an element of the real numbers such that y is greater than or equal to -6. So again, we're saying whatever y value exists on this line is going to be larger than or equal to -6. And again, this is the formal definition. For our intents and purposes, we don't need to necessarily worry about using the formal definition. We just use a short form. So generally, I'm okay if the domain and range you just wrote, in this case, x is less than or equal to 3, y is greater than or equal to -6. Okay, as long as you write that, I'm happy. Now the one thing to be careful of here, because I see this mistake a lot, just be very, very careful with the direction of your inequality signs here. Make sure that you have them pointing the right way. So if you're not sure about how those go, do ask for help, because they can be a little bit tricky if you haven't used them in a little while. But that's generally how they work. So let's take a look at another example right here. This one's a little bit easier to work from because it's not a graph, it's not a range of values. So we have our x values here and our y values here. So remember, our domain is a list of all the possible x values. Well, the only possible x values here are the ones that are listed here. So we have -3, 5, 2, and -6. So we just need to list them. So we would say that our domain is -6, -3, 2, and 5. So I've just arranged them in order from smallest to largest. Just for communication's sake, it's a little bit easier to read, and I would expect you to do that as well. But again, the domain here is rather straightforward, just list the possible x values. For the range, same idea. The only y values we have are the ones listed here, 4, 8, and 12. So that would give us our range. Okay, so again, we're just listing all the possible x values and all the possible y values in a particular relation or function. Yeah, this one here actually isn't a function, it's only a relation, but again, we can still find the domain and range. Okay, so there's a whole bunch of examples here over the next couple slides. I'll do a couple with you, but I'd like you to first go through these next few slides. So I believe there are 9 of them in total. Just write out as many domain and ranges as you can. Some of them, the notation can get a little bit different, so if you get stuck, that's okay. We'll go through them together afterwards, but try to do as many as you can on your own or with a partner or small group, and push play and you're ready to go through them together. Okay, so for this first one here, so do domain then range. So I'm looking at all the possible x values on here. So the only x values that exist are the ones to the right of this point right here, and that x value here is -5. So we have any x value to the right or larger than or equal to -5. For the range, y only exists above this point right here, and that y value is 1, so y is going to be greater than or equal to 1. Okay, so the second one is one of those ones where the notation can get a little bit tricky to work with here. So you'll see here that the line doesn't go on forever in any direction. It goes from this point right here all the way up to here where it stops. Now, if you've never seen an open circle before on a graph, it means that this endpoint is not included. So here, for example, to the left it goes up to and including this point, which we'll say for the x value is -3. But up to here, it goes up to this value of x value of 2, but doesn't actually include it. So what we're going to say here for our domain, the smallest value x can be is -3. The largest value it can be is 2, but not including it, and x is going to be in between it. So any x value you take is going to be greater than or equal to -3. So x is greater than or equal to -3, but it has to be less than 2. Notice that it's not less than or equal to, because I can't put this, because that would mean this point's included. If this was a closed circle here, then you would include the point and put less than or equal to, but it's not, so we can't include it. So the domain is any x value between -3 and including -3, but up to and not including 2. Okay, so for the range, the smallest y value on here is -2, but we don't actually touch that because it's an open circle. So y is larger than -2, or -2 is less than y, and the highest y value is 4, and y must be less than or equal to 4. Okay, and again, you working with the notation will take some getting used to if you haven't used it in a while, but so be sure to ask for help if you're getting stuck in the early going. Okay, so number 3, and again, just getting used to notation here. Number 3 is a parabola. You'll notice here that because of these arrows, it continues on forever to the left and right. So they're actually, no matter what x value you pick, it will exist somewhere on this graph because it continues on forever. So since there are no restrictions on x, the way we write that is we just say x is an element of the real numbers. Okay, so this would be your way of saying that there's absolutely no restrictions on x, and x can be any value inside this relation or function. Okay, so x is an element of the real numbers. As for y cannot be any real number because y does not exist above the vertex here. So the only y values that can exist are ones that are less than or equal to the highest y value right here, which is not the clearest graph. It looks like this is at 7, so y is less than or equal to 7. Okay, for the circle here, let's just take a look. So moving from left to right here, the smallest x value is -1. The highest x value is 7. And the points are all included in between, so x is greater than or equal to -1, but less than or equal to 7. Okay, for the range, the smallest y value, according to this, is -5. The highest y value is +3, and y can be anything in between them, and including the endpoints. So y is greater than or equal to -5, but less than or equal to 3. Okay, number 5. So again, just getting used to the notation here, you'll see that the line continues on forever in all directions. However, there is a hole in the line over here, so this point is not included, so you have to account for that in our domain and range. So for our domain, x can be anything except for this one x value that's here, and it looks like that's at -5. So the way we write that, we would say x cannot be equal to, so the equal sign with a line through it, x cannot be equal to -5. And that's how we say that that's the only thing x cannot be. For the range, the y value at this hole is 4, so we're going to say that y cannot be equal to 4. And we have our domain and range. So it's automatically implied that x can be anything else. Okay, so for number 6, it's an oval, so very similar to the circle we just did. So smallest x value is -3. Highest x value is +3. And for the range, we're going from -4, that's the lowest y value, +4 is the highest. Okay. A couple more. Again, just getting used to the notation here. So number 7, okay, so it starts here and just moves over, continues on forever in this one direction, but stops here. So for our domain, any x value exists as long as it's to the right of 3. So x is greater than or equal to 3. For my range, the smallest y value is 5, but it goes up above there forever, so y is greater than or equal to 5. Okay, number 8 is a very strange looking graph. It might be a little bit hard to see in front of you. These horizontal lines in here are actually not part of the graphs. These are called asymptotes. We'll see some more of these as we move through the course. But these are actually invisible lines that the graph or the relation gets infinitely close to, but doesn't actually touch. So these two lines are sort of invisible barriers that the graphs cannot cross. So what it means is that the graph does not exist on these lines. So just to indicate a little bit more clear on the graph here, we've got an invisible line here and an invisible line here that the graph can get infinitely close to but not actually touch. Okay, and again, they're called asymptotes, and we'll talk a lot more about those a little later on in the course when we deal with certain types of functions. But what this does tell you now is we have restrictions, because otherwise, if you look at the blue part of the graph here, there are arrows on the end. So if I get rid of these so you can see the original graph again, you see that there are actually arrows on the blue portions here. They actually do continue up forever, to the right forever, left forever, and down forever, but you just can't cross these invisible horizontal vertical lines here. So it just gives us some restrictions here. So for our domain, any x value exists except for the one where this vertical line is, which appears to be at -3. So x cannot be equal to -3. And for my range, looking up and down, every y value exists except for where this horizontal line is, which appears to be at -2. So y cannot be equal to -2. Okay, and last but not least, let's take a look at a sideways parabola here. So this one is not a function. We can still find the domain and range, though. So if you're looking at the domain, x does not exist over here. If you move over, x starts at 4 and then goes up forever. So x has to be greater than or equal to 4. Okay, and for your range, you'll notice because of these arrows, it's going to continue going up and down forever. There's no restriction on y, so just remind yourself the way you write that. We say y is an element of the real numbers. Y, Greek letter epsilon, r. Okay, so a lot of new stuff was shown today. We're going to try and apply this to quadratics as we move through this unit. So we are going to get a lot more practice with this as we go forward, but it does take some getting used to. So just make sure to ask for help, and hopefully it'll go okay. So there's some homework there in your textbook. Please make sure you do it, because again, these concepts are kind of tricky, but domain and range will show up a lot throughout this course, so it's important that we have it down cold. If you're going to take 3U next semester, if that's a goal of yours, you'll be doing a lot more with domain and range than even what we've done so far. So good preparation for that as well. Okay, that's it.